Okay, hey Ella and Kylie, if you're watching this is just a video on how I do complex circuits, my thought process through them. Now, this one is a little bit more simple than what we were working on the other day, but I think it still kind of shows what I think. And yeah, so the first thing I noticed about this circuit is we're given all the resistances. So I am going to add all those up to find our total resistance through the whole circuit, then I can get my total current. So, I'm looking at R1 and 2 right now. They are in series with each other, so their resistances just add normally. So 6 plus 2 equals 8. Now they're in parallel with R3, so it's going to be 1 over 8 plus 1 over 4, and that is 1 over 8 plus 2 over 8. That gives us 3 over 8. Flip it around, 8 over 3. 8 divided by 3 is 2.67 ohms for the whole circuit. 2 ohms for this clump right here. Now, this clump is going to be in series with the rest, so I'm just going to add those together normally. So 2.67 plus 1 plus 3 plus 6 gives us 12.67 ohms for the whole circuit. Now since I have two components, voltage and resistance, I can plug in this equation to find current. So, I'm just gonna do 9 equals I 12.67. So I is 0.71. Now, since these are all in series with each other and current is the same through series, I now know the currents of R6, R4, and R5. So this is 0.71, 0.71, and 0.71. Now, since I have 2 out of the 3 components for 4, 5, and 6, I can just multiply those together to get my voltage. Okay, and now I have my voltages for all those. So the next pattern I'm noticing is that these voltages, oops, these voltages are going to add together. These ones right here are going to add with this clump to equal our total voltage of 9. So since they're all in series, voltages add, and the clump is in parallel, so yeah. Anyway, I'm going to do 9 minus 4.26 plus 2.13 plus 0.71. And that is going to give us 1.9. So, since this clump that I just circled, this line and this line are in parallel, voltages are going to equal. So, which is 1.9, which I just found because that's the leftover voltage. That gives us 9. So our 3 is 1.9. And since I have voltage and resistance, I can divide 1.9 by 4 to give us our current. That is 0.475. Okay, next pattern I'm noticing is that this current is all going to be the same, but since these two lines are in parallel, they're going to add together to equal the current of the circuit. So 0.71 is the current of the whole circuit, and we just found 0.475 is the current of our 3, so we know that the other line is going to be the difference of those. So 0.71 minus 0.475 equals 0.235. And since these two are in series with each other, their currents are going to be the same. Okay, and now we have the two components, so we multiply them together to get our total voltage of each of the resistors. So this would be 1.4, 4.1 I'll say, and this is 0.47. Okay, and a nice little way I like to check my work is normally if you have a circuit that you're given a bunch of different little stuff, I like adding up all the resistances to check my work. But this one, I'm going to add up all the voltages to make sure like it all makes sense. So what I'm looking for is that R1 and 2, the voltages are going to add to equal R3. And then this clump is going to add with the voltages of this to equal 9. And then that's the way I'm going to go over and check my work. So 1.41 plus 0.47 should equal R3. Which it does. I got 1.88, but we're going to round that to 1.9. And now 1.9 plus 4.26 plus 2.13 plus 0.71 should equal 9 volts. And it does, it equals 9 volts. So that's just a quick little way I like to check my work. But, yeah. So, helpful steps I found in this is that current is going to be the same throughout the whole circuit. Voltages are going to add. And then, of course, the resistances you add in that way. And then in parallel, what helped me is voltages are going to be the same. So, for example, this voltage is the same as that voltage. But then this I'll add with this to get our total voltage. And then current, this current plus that current is going to be equal to the rest. So yeah, that's how I did that. This is just the way it made sense to me. I know it's kind of like rushed and whatever, but you kind of have to recognize the patterns you see, and it'll like remember the rules, and you can like unlock a new component of a new like resistor I like to think about, and then you just use those rules to find others. Anyway, that's it.